move on from there. And so my name is Tim Brown. I'm a research scientist here at the University of Iowa's National Advanced Driving Simulator. I have been doing driving simulation research. I started back in 1994 as I was finishing my undergrad work here at the University of Iowa, and have been doing it ever since. Um, so I've got a few years of experience doing this, and hopefully some insights that are useful to share. Currently, I am the Director of Drug Driving Research here at the National Advanced Driving Simulator. And for better or for worse, as part of this, I should also point out that I am a member of the University of Iowa's IRB, Institutional Review Board. And so I will bring a little bit of that perspective in there as we go through. So as we said, this is the fourth webinar in the series. So far, we've covered a brief overview of simulation, one on experimental design and one on scenario design, development, and testing. And so those have all been important topics and kind of lead up to this next step, which is conducting simulator studies. So this is kind of the first step into actually getting good data, and we're going to try and discuss how we get good data in an ethical way, as we kind of lightheartedly say, how do we get good data and not get in trouble with the IRB? Some days that's all we can hope for, but we'll hopefully share some insights as we go through today. So coming into the study, you've kind of got an idea of what your experimental design and protocol are. So those were specified early on in the process as you were designing your study, and that kind of shows up at the top of our slide here. And what we really want to get out of this at the end is we want to get good data. That's, as researchers, that's kind of our main concern. We want to get IRB approval, so we don't want to propose anything or do anything that's going to cause ethical concerns. And something we also often don't think about are satisfied participants. At one level, our sponsors are our customers, but our participants are also our customers. If we don't make this experience good for them, they're likely not to come back for future studies, and they may tell their friends, families, colleagues that they are not, they don't want to do research for us in the future because of a bad experience. So as part of this process on conducting simulator studies, what we really need is a documented set of experimental procedures. And we've got a nice little display up here of all the kind of things that go into that, from a recruitment plan to what the elements of consent are, how you communicate with participants, what those procedures are in there in terms of collecting the data both before, during, and after. How do we assign subjects to conditions or participants to conditions? How much should we pay participants? Is our staff trained? And then at the very end, you wind up with the data verification, validation, and also record keeping. And so there's a sequence to this. And so the next slide kind of shows kind of at least how we envision that you kind of move through the steps in this. It generally follows the steps outlined here. The first is kind of that experimental procedures must be fleshed out. You've got a good idea as you're developing your protocol up front, what you want to have happen. But if you're like most of us, as you flesh that out, it's kind of in broad strokes. This is in general what we're going to do, but it doesn't get down to that step-by-step process that you need to follow in order to collect the data. And so this is kind of where we start fleshing that out, and we do that before we get to the IRB application. And so we want to know what those steps are. Every IRB is a little bit different, and we'll talk about that later. But we want to know what those steps are as we envision them, so we can put it into the application accurately. And while we're waiting for the IRB approval, one of the steps that we find very important is staff training. Every study is a little bit different, and just because you've collected data for 25 years doesn't mean you don't need to be trained on how to collect data for this particular study. The procedures are different. We've got some very good data collection coordinators here at NADS, and even I, as the PI on studies, have to get trained because although I've written the broad strokes, they often go through and do the work of fleshing out the step-by-step, and sometimes my mental model doesn't match theirs, and since they're the ones conducting the study, I need to learn to do it the way that they're telling everybody else to do it. Pilot testing, which is going to differ from scenario testing, which we've talked about previously, is another important step. It's where we verify that everything's working smoothly, not just with the scenario, but with the whole process. We move on to data collection and source documents. We need to make sure we have the appropriate documentation so we can mark what happens as we go through. We'll talk a little bit about that. It's an important step, and it's often one that's overlooked in terms of the process of collecting simulator data. We need to verify and validate the data as we're going through. The last thing you want to do is get to the end of the study and realize that something went wrong and you didn't realize it, and so you've got a ton load of data that's not useful. And then the final step is kind of what is that end record keeping? How do we document things so that when we come back 2 years from now and want to write a paper, we know what happened and we can accurately go back and look at the data. So kind of starting with the developing of experimental procedures. This is, as I said, this is a step-by-step instructions on how to collect the data. They cover who does what and when. At a simplest level, for students to collect this data on their own, it can be relatively straightforward. But it quickly becomes complicated when the study is complex. On the screen there, I've kind of popped up a listing of a schedule for one subject over the course of a day for a drug driving study that we had done, where they arrive at where we have our first interaction with them at 6:18 in the morning, and they're with us until 4:50 in the afternoon when they finish their study procedures. And so as you look there, this is a study on alcohol and cannabis effects on driving. We've got lots of steps along the way, and it's down to the minute in terms of what happens when. But you can even take simpler studies, and this is an example of a study we've got over there where we're doing simulator drives and we're doing consenting some surveys and some training beforehand, and we've got 2 participants running at any given time, and we've got 2 researchers that are involved in helping conduct that research. And so as you can see, there's a lot of coordination that goes back and forth, and we wind up with having to time that out so we know that the researchers aren't supposed to be doing 2 things at one time. It allows us to be as efficient as we possibly can in terms of collecting the data. So I've got a quote on there to start us off with. A goal without a plan is just a wish. And I always wish to have good data, but if I don't plan appropriately, then I'm not sure that I'm going to get that good data out at the end. And the last point on here is relates to not only do we care about what happens when, but who's going to say what and what information we're going to provide to the driver. And we'll talk a little bit about this later, but here's an example of 2 different ways we could instruct a driver on the speed limit in a study drive. In one case, we could say the posted speed limit is 55 miles per hour. Another way we could say is please maintain 55 miles per hour. And each has different implications for how the driver might approach it. So with the first, it serves as a reminder of what the posted speed limit is. It still is giving the participant an opportunity to choose what speed they want to drive, knowing what the speed limit is. For the second one, it's much more of an instruction, and it clearly indicates some preference that we've got. We say, please maintain 55 miles per hour. We're more likely in the second case to get speeds close to 55 miles per hour, but there might be unintended consequences of that. If we have the driver might typically drive faster than the speed limit, they may be less likely to do so. If a driver is inclined to slow because traffic is getting more dense, they may be more disinclined to slow down because we've told them to maintain 55 miles an hour. And so that could result in a shift from a braking maneuver to a steering maneuver if the driver thinks that they're not supposed to slow down in response to driving conditions. And so those are things we just have to be cautious about as we walk through the process of setting up the experimental procedures. And there are valid reasons for doing both. We've done studies where it's very important for the drive and we don't really care about what their speed profile is, that they're at a particular speed. And then in that case, we might say, please maintain 55 miles an hour, or please maintain this posted speed limit. But when we care more about some natural variability in how people are going to approach things, a more general response on reminding them what the posted speed limit is may be more appropriate. So that leads us to getting IRB approval. So we've gone through all the work and we've kind of got an idea step by step of what we want to do. We now have to request IRBs. And, one of the questions you get is, in some cases, what is an IRB and why do I need approval? There's a variety of challenges here as we go through this process. But over the years, there have been many examples of people who've done things that ultimately were not the most ethical ways of collecting data. And we've learned from those over the years, and that's one of the reasons institutional review boards exist, is to provide some oversight to make sure people aren't stepping out of the bounds. And so, some of the examples that include in there are the Tuskegee syphilis study, where people were deceived into thinking that they were getting treated when in fact they were not. And so people had syphilis and did not get treatment when they otherwise would have if they hadn't been told that they were getting treated. Another big example is back during the Cold War with radiation studies, where people were exposed as part of weapons testing to various levels of radiation. These things included things like plutonium injections. Prisoners, where various parts of their body were exposed to high levels of radiation to see what the effect would be on reproductive function. Cancer patients with whole body radiation to see what the impact of those high levels of radiation would be on people that were ill. And even here at the University of Iowa, a study from back in the 1930s which is referred to as the monster study, where studying was induced in orphan children through this use of this procedure. And those are things that, they provided valuable information to the researchers, but from an ethical standpoint, cross some lines it would not be permitted in today's culture. And I think we learn from those and we make adjustments as we move forward. So one of the things to keep in mind is that the IRB process is different at each institution. There's still some IRBs around the country that, as I understand, still do paper IRB applications. Most have moved onto electronic forms, but the steps you take and the forms you fill out are a little bit different as you move from place to place. And so one of the things we tell people to do is talk to researchers around them to get advice. When we get new researchers here, we often encourage them to talk to our research coordinators to get an idea of what the IRB is expecting, what sort of answers they're looking for, and what some of the pitfalls might be. And so when you've got that expertise, you want to make use of it to the best extent that you can. The other option is to look at and see what training your institutional review board offers. Normally they all have some, and it can be very general on how do you submit an application, kind of what are the steps in filling it out. It can be a little more focused in terms of what are the office hours for when you can go in and you can talk through what you're trying to do and see how what concerns that raises on the part of the IRB staff. And one of the things that we do here, particularly I reference, we do a lot of drug driving research, and as we go into that, one of the things we wind up doing a fair amount is scheduling meetings with our IRB chairs. And so they have regular meetings and we go in and we talk about what we're planning to do. And this is even before we've kind of designed what the overall protocol is and say, what are the constraints on this research question? This is kind of what we're thinking. What concerns would you have if we went down this path? Are there particular areas you want us to pay particular focus to? And so those are valuable conversations. And I know sometimes it is very enticing to just say, well, I'm going to do it the way I want to and hope it works out, and maybe the IRB won't have problems. But it's a lot easier to fix it up front and design it in a way that's going to minimize problems with the IRB in terms of things that they will not or can't approve than it is to design everything and then have to go back and try and negotiate with them on what you can do later. So one of the things to keep in mind is that on IRB, timing is important. You want to get your IRB application as soon as you can. again, with every institution being different, the amount of time it can take is greatly variable. Our IRB asked for about 6 weeks from submission until getting an approval back. That can vary depending upon whether or not it has to go to a full board or whether or not the staff can review and get an IRB chair to sign off on it. You should know what the timing is for your university and what the turnaround is. But at a minimum, you've got to have the protocol and procedures outlined before you submit the application, but you want to get it in as quickly as you can to maintain your timeline for your project. The other thing you can keep in mind from an IRB approval standpoint is everybody that's going to collect data has to have human subjects training. And so here at the University of Iowa, as with most places, I think they use city training, which is a great site, and you kind of do it offline. I remember the first training I did was in person, and it's particularly more painful in person when you spend 6 to 8 hours in a room learning about IRB processes than when you can chunk it and do your training over short bursts of an hour and a half when you've got time. But you do want to make sure everybody has the appropriate training moving in. And I guess the last thing on this one, as we talk about IRB approval, is make sure everything's been reviewed. Just like you would with a manuscript, you don't want to call attention to there being potential problems by having things be in rough form when you submit them. If there's spelling errors, if there's errors in terms of what is how a procedure is described in one place versus another, those are the things that cause problems and cause questions and often result in delays in getting things back. As an IRB member, if I'm given the primary review for a proposal that's being considered by the IRB, as I look at the application, if I see problems and grammatical errors and other things in it when it gets to me, my first thought is what else is wrong? And that poses problems for you because it may just be that you didn't do a good job of editing, but procedurally everything's good and lined up. But I'm taking a deeper look because I'm concerned if you didn't even get the surface stuff right, that there are going to be deeper errors elsewhere in the process. So as we think about recruitment as one of the first things we need to plan out in a study, we need a recruitment plan. And the recruitment plan focuses on a variety of things. The first thing we focus on is kind of the who of the question. And we define the who through a series of inclusion-exclusion criteria that we set in the project. Who do we want to have participate in this? What are they supposed to be representative of? They're going to be defined in the experimental protocol, but this is kind of where you operationalize them. When I say I want normal, healthy drivers, what does that mean? We can look at things like age, sex, socioeconomic factors, driving experience, race and ethnicity. How representative of the overall population do I want this to be? And that the answer may vary. If I'm looking at how a crash warning system works, I maybe want a broad sample across everything. If I'm doing research on how teens respond to distraction, then obviously my age factors are going to change. If I'm looking at how a certain medical condition impacts driving performance, and what we're really focused on is a disease that focuses largely on males or females, that I'm going to recruit that population rather than a general population. The other thing to consider is proximity to the facility. For a lot of research, this doesn't really matter, but it matters for a lot of the research we do, particularly when it relates to impairment. Whether I'm doing a drowsy driving study, an alcohol study, or a drug driving study, if I've got to be responsible for transporting them to and from our facility, I really don't want them living 200 miles away. That's an awful expensive taxi ride back and forth to their house to get them to participate in the study. So we sometimes will set research or boundaries about how far away they can live and still be in the study. And then there's a variety of other factors that are called in there related to experience. Some of the ones I'll call out particularly to focus on are experience. Should you reuse participants from previous studies? If so, which ones? So, for example, if I'm doing a study where we're looking at crash warning systems, do I want somebody who's been in a previous study where we looked at that same type of crash warning system only 9 months ago? Is their response likely to be affected by by their participation in that previous research? And so you got to carefully look at what prior experiences you want to allow in and which ones you want to exclude. If we're looking at new advanced technologies, one might argue that I want them to have experience with that system. So if you're doing a study on adaptive cruise control, you might want to have them test people who've had some experience with it, but not if you're doing a novice study where you're looking at people who are using the technology for the first time. And so those are questions you've got to answer, but they factor into the inclusion-exclusion questions you have to ask. Other questions that focus in there are medical issues. We often screen out for people who have histories of motion sickness. If they've got particular illnesses that might interact with what we're testing or might cause problems when they're participating in the simulator, that's something we care about. So those are things that we all work our way through, and you've got to work through and come up with what answers are acceptable and which are not. As we start talking about who, we get into the question of using a convenience sample. Do we use people that are the easiest to recruit, or do we try to get a broader sample? Oftentimes, particularly if you're at a university, it's easy to get students. So it's easy to get participants who are 18 to their early 20s. And that's always one of the things as a reviewer I look at. And, if research comes out and says you're trying to generalize to the broad population and your minimum age is 18 and your maximum age is 28 and your mean age is 21, how representative is that sample? And how representative is it? Likewise with friends, oftentimes they're easy to recruit, but they may know too much about what you're doing, and they may not be good subjects. So one of the things that seems to be more of the fashion now, and we've started using them more regularly, is online screening surveys to determine eligibility. It allows you to screen a lot of people very quickly to determine whether or not they meet the criteria to be in the study, and then be more selective about getting a broad sample rather than just getting the people who respond first, who may not be as representative of the broader population as those who respond over time. So continuing with the recruitment plan, we also need to consider when our population is available. And it may differ by group you're trying to sample. So schedules are always complex. I know we'd like to collect data kind of between the 8 and 5. It's a very easy time for us as staff. It's when we're normally in the office, but it's also when some of our participants are in the office and not able to participate in research. For students out there, 8 to 5 might not be great for you as you work around your class schedule, but those are things you need to consider. Evenings and weekends may be the best time to get a diverse sample, and you may need also those in addition to those times during the day. And sometimes you need to be more flexible. Different populations come into play here. We like to generalize and say, okay, we want to get people who are 30 to 50 years old, and we might say, oh, that's the working population, so we want to do evenings and weekends to get them in. But that might exclude stay-at-home parents who may have some more time during the day, or people who work alternate shifts. So those are things to consider as you're working out your schedule, but you want to make sure it aligns between you and the people you're trying to collect data from. The other thing to keep in mind is you may not be able to cover the data with just one person, particularly as you expand this out. Whether it's a professional staff or students, you want to look at how else you can pull people in to help with the data collection to make sure you can cover when people are available. So getting people to volunteer, that's always a struggle. We'd like to say that people do it out of the goodness of their heart, but they all have their own reasons. College students may be more inclined to participate for money. If they're taking out student loans and trying to get by and get a little extra spending cash. That may be why they're doing it, or they may do it for class credit. We've experienced that some of our older participants, particularly those that are retired, will often do it just to have something to do, and so they do it as a social activity. You get a group of them that all volunteer for the same study, and then they go talk about it over coffee on subsequent days. And so, a lot of it's generalizing, but you need to think about what their rationale is for participating and how that factors into your ability to recruit them. And having a better understanding of who your people are that are going to volunteer and why they want to volunteer helps you design the recruitment plan better. Which brings us to compensation. How much do you pay, and if anything, that wad of $100 bills in the picture probably would be considered coercive and would probably not be approved by the IRB for most of the research we're talking about doing in driving studies. That having been said, you need to find that spot, and it needs to take into account what the difficulty level is of the research, how long it's going to take. We pay extra if we have to draw blood. People don't like to have their blood drawn, and so doing blood draws gets extra money in the compensation for those studies compared to other studies that take the same amount of time. People obviously, as we think about how you're going to pay them, cash, gift cards, issued checks, there's going to be institutional requirements. I know here at the University of Iowa, the preference is to issue a check. However, there are ways of doing cash and gift card, which subjects seem to prefer over waiting for a check. And then finally, how much is considered coercive in terms of trying to get them to participate in the research? You can't give them a trip to Paris in exchange for giving blood. So we want to sweeten the pot if we're going to make them do something out of the ordinary, but we can't make it so much that they're going to do it regardless of how risky it is for them. And then finally, as you recruit in the recruitment plan, you need to keep in mind special rules that apply to children, teens, pregnant women, and those with certain medical conditions. And so as you go through the recruitment plan, you need to take into account what those rules are at your institution and making the necessary steps to make sure you're protecting those subjects. So with this, we're going to kind of go to our first interactive poll, and Jacob is going to pull this one up, which is going to look kind of like my slide, except it's going to allow you to respond. So which methods do you use for recruitment? I see votes coming in. There's lots more people than that are voting, but we're seeing the numbers move. So I think I don't see too many more votes coming in. There's a few more coming in. Jacob, can you broadcast the results? I'm not sure what it looks like on your end, or maybe I can do it on my end. So as we look at it, it looks like 75% of the people wind up using flyers, which is a common way. It's one of the ones we use. Word of mouth is on there. Email seems like they're the three big ones that people are using: word of mouth, emails, and flyers. As we've looked at it, we've done a lot more social media recently, and that's a good one. We've also done some work with the online advertisement using Facebook and Google to do targeted advertising when we're trying to get hard to capture populations. I see that no one marked paid media. We may be a difference here, but we've used that periodically over time, and so we're going to dig into a little bit more on this. But it's interesting to see how people use it and what the implications are for different people in terms of which works best. But there are a lot of different options, and we'll talk a little bit more about that next. So Jacob, can you, I don't know if I can move on to the next slide or not yet. There we go. So recruitment. We've got a plan. Now we have to have a strategy. And so I've got a couple of pictures here to start us off. I'm an engineer, even though by training, and so I've got the nice picture down there with Dilbert's boss down there, and he's got a plan. It seems like it has a timeline. It's unlikely to work if it's coming from Dilbert's boss, but there's some hope. At least there's a plan. And there's a quote I like: "No battle plan survives contact with the enemy." This can be translated into no recruitment plan survives the first wave of recruitment. It seems like every time you start, there's something you don't count on, and you're not getting the sample the way you want to, even though it's worked in the past. So we're going to talk a little bit about that. This is really about strategy. How do you find the sample you need? You're going to recruit through, external organizations. So this is often popular when you're using special populations. So if we're trying to recruit teen drivers, we might want to recruit through schools. If we're recruiting older drivers, we might want to recruit through a senior center. And so there's a lot of examples that you might look at. If we're going to try and recruit, we're in Iowa and we're trying to recruit a sample that's more racially balanced than the general population of the area might imply, we may look to student groups that have different populations or different community organizations that are focused on serving the needs of different ethnic groups. And so there's different ways of doing it, but one of the things you have to think about is what are the rules of those organizations, and depending upon what your university or IRB calls for, you may have to go through some hoops of obtaining letters of agreement in order to be able to recruit there. They may want to see those before they approve your recruitment approach. Mass emails, they tend to work well, but you're going to get a tsunami of responses. So plan ahead. You want to make sure you've got enough staff and students around to respond to those as they come in, because what you don't want is to send out a mass email to thousands of people and only need 5 people and take weeks to respond back to people, because that won't leave a good taste in their mouth. Social media, you need to think about what you can use in terms of your institution. But there's also challenges there depending on the approach you use. Things get shared very easily. People can start commenting on them, and so it may, if your research has any negative aspects to it, if you're studying something people are not in favor of, you run that risk. So if we're doing drug driving research and we do a lot of social media, does our posts get it pulled into a debate between those that are in favor of legalization of marijuana and those that are opposed? And so that's not what we're trying to do. We're trying to recruit people, and we don't necessarily want to get sucked into that. So we need to consider what the implications are and how we can use it most carefully. The other issue you get into is, in a social media era, do people, after they participate, get on and disclose to the world that they participated in the research and share details about what happened? And so those are things to consider as you think about strategy, because there can be a breach of confidentiality if they comment on it, and now everyone knows that they were in this study looking at the effects of marijuana. And word of mouth is a very common one. It can be effective, and data collection goes along. And so one of the things to think about is, depending upon your IRB, some will even allow for referral fees to be paid, which may make life easier for studies where populations are difficult to get recruited. As we look at the recruitment effort, how long does it take? It varies based on the sample size and the restrictiveness of the inclusion-exclusion criteria. So the more restrictions you have, the longer it's going to take, the more money it's going to cost, the more pain and suffering you're going to have as you go through the process trying to get your sample filled. Which approach comes first is really going to be, there's going to be some judgment on your part in terms of how to do that. Recruitment is going to be easy. You don't really want to take the big approaches of going social media or mass email, because you may not need that big sledgehammer to get your small sample. You want to have a plan in advance, and you want to look at what point you move on to other steps along the way, and when you get to the sample you want at the end. Recruitment materials. I like my Dilbert comics here. We'll throw this one out as we move into it. Our highest priority is satisfying our customers, which in this case for us is the participants, except when it's hard or unprofitable or we're busy. And sometimes when we get busy, that's when we lose sight of making the material easy to use by our subjects. We're in a rush to get data collection moving, and you don't go back and you don't make sure the informed consent is as clear as it should be, and it leads to confusion. Recruitment material isn't clear, and we wind up with a lot of people contacting us who turned out not to be eligible because we weren't clear in what the criteria were. But overall, some major things to consider are without the participants, there's no research. We need to make the process as easy for them as possible, make them feel important and valued. And here are some hints that we've learned over the years. When emailing them, use an email address that is checked regularly and looks official. An organizational email is preferred rather than using Gmail or AOL. That way they know they're contacting somebody that's affiliated with the organization. So if you've got an organizational email, use that rather than a personal or a side email. Use a number when using phone calls. Use a number that someone's going to answer the phone, and so make sure it's a voicemail box that's regularly checked if someone's not going to be there. But if you're going to do a set of emails where you ask people to call in, make sure there's somebody there to answer phone calls as they start coming in. Try to use only one phone number for contacts, otherwise you're going to run into confusion. We've had that a few times when we've had people using different phone numbers, and they call, rather than calling the number we give them, they do a redial or call back and call the number the phone was that the person called from, and that results in messages being missed for hours or days sometimes. And then keep track of your contact with the participants. Have a system and use it, so know how many times you've contacted them. Know when they've said, I'm not interested in this study, so you don't call them back 3 days later and ask them if they're interested in participating. So the next step, or next thing we wanted to talk about is informed consent. What is informed consent? This is one of my pet peeves when I review things, is when people seem not to be clear on what informed consent is. It's more than just a signature on a piece of paper. It's that critical first step. It's where we find out from the participant that they are willing to undertake the experiment that we've laid out. So we need to be explicit. It's an explicit acknowledgement and agreement between the researcher and the participant on what's going to happen. We need to be clear on what the purpose is, what the duration, what the procedures are, and most importantly, what the risks and benefits are. So what risks might they encounter? What are the benefits to both them and to society for participating in the research? After they've asked any questions and you've answered them, they can decide whether or not to be in the study. This is not just a pro forma step. There are people who will come in, learn about the research, and I know it can be annoying when you've talked to them on the phone and you think that they know what's going on, and they come in and it gets to the point where they ask questions and they decide that they don't want to participate. That's their prerogative, and they have to have that option, or it's not informed consent. And so this is kind of how I like to envision the process of informed consent. The researcher is providing information to the participant. The participant is providing that consent, and based on that consent, we continue to provide more information about what's going on. At any point during the visit, as this cycle is going on and we're conducting the research, the participant is capable of withdrawing their consent from that study and ending their participation. Now we're going to get a little bit into the weeds on some special considerations as we're going through, and one of which is the ability to consent. Generally, as we walk through this process, we don't worry about this too much. If they're a licensed driver, they should obviously be able to provide consent. That's kind of a general rule of thumb we use. Our IRB has said that that's kind of what they assume as we're doing research, that if somebody's got a license, from a societal level, that they should be able to provide consent. But there's cases where that's not necessarily true and where it matters. And so as we walk through, there may be medical conditions that affect mental state, and there's also things that we can do to the driver that affect their ability to consent. And so one of those areas that we get concerned about is as if we're using an elderly population or a population that maybe is in the process of early onset Alzheimer's, or we're looking at medical conditions associated with that. And their ability to consent can change. And so one of the things we use is a mini mental state exam to provide a standardized and validated approach to assessing the capacity consent. And so we use that if there's any uncertainty about whether or not the person's able to consent. And so we call that out in the IRB application when we've got concerns, and we say what the criteria will be if we move into that process of doing it. And the challenge is this could change if you're doing a longitudinal study and somebody's got Alzheimer's or is developing Alzheimer's. They might have been able to consent when they started the study a year and a half ago, but now they're at the spot where they're no longer capable of continuing to provide consent. And then you've got to go into obtaining consent from somebody who is legally capable of providing consent on their behalf. The other area where that can change is studying children who reach the age where they must consent. So if you think about if you're doing a longitudinal study looking at pedestrians or bicyclists, and you start them off when they're 5 or 6 years old, all of a sudden it's 6 years later and they turn 12, and now it's not enough that their parents consented on their behalf. They have to provide some assent or consent in order to continue to participate. And so those are things to consider as you look at those research questions. And that brings us to research with children. If they're under the age of 18, we may need their parents to provide that consent for them, in addition to getting consent from their parents. And so for most of the stuff with drivers, kids who are old enough to drive, we get consent from both the parent and the child. If you start looking at younger ones, then you're going to get consent from the parents on behalf of the child, but the child also must agree to consent, and that is going to be what's referred to as assent. And it generally has the same general information, but it's in a much simpler format so that the child can understand. And rules are going to vary. They vary by institution. Different state laws come into play in terms of when people can consent. And your institution will know what those rules are, and so it's important to work with them on figuring out where you want to be at with work with children. And coming back to the older adults, our experience tells us that special care must be taken with these participants. As individuals age, they become more increasingly concerned about their performance and being judged. Make sure that they know what is being studied. Most often it isn't them. And also remember that you most likely are not trained and qualified to judge their driving. That's one of the common things we get with older participants when they come in is they're worried about how well they're driving, and they're asking for some validation about whether or not they're still safe to drive. And unfortunately for them, and we need to realize that most of us are not qualified to provide any input to them on that. We just know how they drove in our simulator study, and that's not and just because they drove well in the study doesn't mean that they're safe to continue driving on the road. And just because they may have had a crash in our simulator doesn't mean that they're unsafe. And so we just have to be careful about how we're interacting with them and what information we tell them. So the other thing to keep in mind with working with older participants is they may require more time to complete procedures. Our experience tells us that they like to read things more thoroughly, and so whereas some of our younger participants will rush through things, they like to read the informed consent and make sure they fully understand it. They like to read through the instructions on the surveys and make sure that they're doing them. And you want to make sure you build that time into the process and not just assume that because younger participants rush through things that all your participants will. The other thing to keep in mind is recruitment can be more challenging. Our experience is that they share both good and bad experiences. If they have a good experience, it can really help with our numbers in terms of recruitment. But if they have a bad experience, then it really causes problems. And this is one of the things to keep in mind as you're as you're working through things. The other special topic we want to talk briefly on, it's not going to affect most of you, but that's certificate of confidentiality. For some research, extra protection of participants may be needed to protect their confidentiality, and I'll reference specifically our drug studies, where drivers have to self-identify as users of the drug in question. And so if we're looking at people who are using cannabis, which is not legal in the state of Iowa, they are disclosing information that puts them at legal risk. And so a certificate of confidentiality protects disclosure of this information to law enforcement or others. And so if we get a subpoena, we would not have to provide information to whoever was subpoenaing us for the information. And so we've got to consider when you need those. For NIH studies, these are automatically obtained if it's an NIH project that would require one. For other studies that are not funded by the NIH, where you might want one, you're going to need to talk to your IRB and the NIH about getting one. They're generally submitted through the organization that would typically have funded it if it were an NIH project. And I've got a hyperlink on there that talks more about certificates of confidentiality. Next, we're going to move on to risks. Simulator studies have no risks. That's kind of our general mindset when we move through this. And so, and I think true relative to on-road studies, the risks are generally less. But that's largely because we remove the risk that they're going to die, which is the biggest risk in comparison. And so just because we've taken that biggest risk out doesn't mean that there aren't still risks involved. As we kind of walk through some of the risks that we commonly identify in our research, one of which is simulator disorientation or motion sickness. And this is always a risk of simulator studies. And the extent of that needs to be disclosed so that participants know that they may experience these symptoms and that they tend to go away, but it is still a risk. Some risks we don't think about as much are emotional risks. What happens when you put somebody in a crash situation? It can invoke an emotional response. We had a participant maybe 2 years ago who came in and was participating in a study and had reported no crashes in their last 5 years on their demographic survey. But we put them in a crash situation and they responded very emotionally to that crash compared to others, only to have found out that they had more than a half a decade ago had a crash that was almost the same as that one where they had been injured in that crash and had been transported to the hospital and had to recover from that crash. And so we don't necessarily know what we're getting into, but you need to be prepared for that. And we need to disclose the fact that there can be emotional risks associated with that. Obviously, we don't necessarily want to call out that they're crash related, but we have to disclose that as a potential risk. Loss of confidentiality is always a big one. It's the one we always throw in. It's also one we don't necessarily think about. What are they disclosing to us in terms of their background, their history, their driving history? And we may ask questions about alcohol and drug use that is information that they wouldn't want getting out to the public, and there is that risk that those files get hacked and that information becomes available, and that is a risk. Although we take lots of steps to minimize it, we still need to disclose what those risks are. And the last one is one we don't think about too much at all, which is kind of a negative transfer of training. If I put someone in a driving simulator and have them go through a challenging drive where there's risks of crash and they successfully avoid it, it may increase their perception of their own driving ability and put them at risk in the future. And Jacob, I'm having problems moving to the next slide. Oh, it moved now. So Impairment studies. I've thrown this one in. I'm not sure how many of you guys are doing work on impairment, but I'm just going to throw out a few important things to think about if you're going to move into that direction. There are extra risks for impairment studies, and those need to be considered. Some of the things to think about as we look at that is, can they get safely to and from the simulator site on their own? Obviously, if we're going to give somebody alcohol or drugs, we don't want them driving themselves home after we've dosed them. And so we need to think about how we can transport them. Do they have to bring their own ride to and from? Are we providing a taxi? Are we having somebody else drive them? When is it safe for them to leave our facility? We want them to be basically nominally back to normal when we let them go. For some of our alcohol research, for example, we dose them and we want them to be under 0.03% BAC before we transport them home. What is that criteria? And then other things to think about is when can they resume normal activities. We often tell them that they should go home and remain at home the rest of the day. That's our advice, but we can't necessarily control that. We've done that with some of our drowsy driving studies where we have them drive after having been up for a long period of time. We don't want them out and about moving around. So next up is deception and debriefing. And I'm going to pick up the pace because otherwise Jacob's going to yell at me when I don't finish on time. And here the question is, can you tell participants only part of what will happen to them? If I'm doing a crash study, I don't necessarily want to tell them we're going to study your response to a crash warning system, because that's going to have them looking for a crash, which is not what people normally do when they're driving. And the answer is probably yes. There are cases where we can do this. It has IRB implications, and what you often have to get is what at the University of Iowa is referred to as a waiver of the elements of consent, where we provide information in general about what they're doing so they can make an informed choice about whether or not they want to participate, but we leave out this critical element of that it's a crash avoidance study. We may tell them it's a simulator fidelity study. We may tell them it's a pilot study for something else. So there may be some deception in there in terms of what the true purpose is, but they know enough to have an understanding of what they want to do. One of the things to keep in mind is that participants may respond negatively to this and to being deceived, and so you need to be prepared with that. One of the best ways is to have a statement prepared in advance that you can share with them as soon as you're done so that they know what was going on and why. And most often and why the deception was necessary, most often people respond fine to that. But you should be prepared for some negative responses, particularly if the drive didn't turn out well for them. If they wind up being in a crash, they may take it out on you in terms of being unhappy with you. One of the concerns with anytime you have to use deception is that they tell their friends or family about what happens during the study. We often ask participants to not share details of the study until it's over, so we generally give them a date and say, could you not, if we were doing a study that ended at the end of May, we may tell them not to share any details on the study until the middle of June, just in case it runs over. So we're going to come back to planning. Plans aren't everything. Plans are nothing. Planning is everything. We want plans, but what's most important about it is the planning process to make sure we've thought things through. Even if the plan doesn't work out perfectly, we're aware of what the risks are, what the challenges are, and we can move through. And this includes as we move into the data collection, things like source documents. And so we do a lot of work on the clinical side, and so we're more familiar with the source documentation and how that moves through the process. But having a sheet of paper where it lays out the data that needs to be collected by the experimenter as they go through, whether that's the time the simulation starts, or what the height and weight of the driver is, or issues that pop up and driver response to things that occur during the drive, those are all important things, and a source document allows you to capture those. Folders using mail merge in the Office product is one of the things that we use to minimize mistakes. You can have an Excel spreadsheet, and then you get your labels printed out, you get your forms printed off, and they've got the subject numbers pre-written on them, minimizing the possibility of errors as you go through. Logistics, get your schedules organized. We've talked about this before, but at the end of the day, you want it all to go smoothly, and you want to have staff available when you've got people scheduled to be in. Making sure the training's complete. This is a critical factor that often gets overlooked as you're rushing in because you think everyone knows what they need to do. But you want to make sure that you as the chief investigator know what everyone's going to do and know that they know what to say and what not to say. And finally, as you kind of go through the planning, is what behaviors are acceptable and valid for data, document everything outside that range. And so looking at a study we did, we may design a scenario where you can go within 10 miles an hour of the speed limit and the event works perfect. And if you're outside that range, it doesn't. And so we look at that as a criteria when we're watching the drive. If they're outside that range, then we can document it. And we've got a question online, which is are there any particularly effective methods you've used to document unexpected events, acceptable data? And we've got sample source stocks that we've developed over time that we use. One of them is called the chronological record of enrollment, which is kind of we use them for non-clinical studies where we basically have boxes that have to get filled in. And we're more than happy to share those. If you reach out to Jacob or to Dawn or to me afterwards, we can share some examples that we've got, and maybe Jacob can even get them posted off onto the site where these webinars are being posted as a resource. They're valuable, and the level of detail you need to get into depends on how complex it is. But really, the critical aspect is to document and provide spots that need to be filled in for every piece of information you want to be collected. So pilot testing is the next thing on the list. And so when we talked about scenarios, we talked about scenario testing and making sure that the scenarios worked as you expected them to. And pilot testing is not the same as scenario testing. We can be doing scenario testing as part of pilot testing, but it's further down that process. We're doing this at the point where we think the scenarios are ready to go, but we want to expose our entire process, both of the scenarios and our procedures, to people who are not familiar with them. And that's a critical spot in the process. And so we can identify when things go right and when things go wrong. I still remember when we did our first study many, many years ago, back in the 90s, we were doing some testing and we thought everything was perfect. And we were bringing our first naive people in to do it. And we had our sponsors there as part of it. And we're watching this, and we had this event all timed out. It worked perfect. And it was a crash event, and the driver is driving, and this car pulls out in front of them. There's cars oncoming to block them from steering, so they would have to brake. The driver slams on the brakes, floors the gas, goes around the car, and avoids the crash without having to slow significantly, because the blocking cars were set to arrive at the truck at the car pulling out at the same time as the driver, and they were heavy trucks, and so they slammed on the brakes and they couldn't accelerate back up. And so the scenario broke completely, and we all scratched our heads, and none of us had tried doing that. But you bring in somebody that doesn't know what they're supposed to do, and they do what they think they need to do, and oftentimes it can cause problems. And so this allows us to work through some of those issues, both on the scenario side and on the procedure side, and make those tweaks. So we can change instructions, we can change the scenario. At the end of the day, the goal of pilot testing is to make sure that everything works well. And this is often a staged process where you do a little bit of testing, maybe with internal participants first who are naive to the procedures, and then you bring in externals afterwards to make sure everything works. And so skipping it sometimes happens, but it doesn't necessarily lead to the best results. And you may wind up throwing away the first set of participants you recruit for the main study because things didn't go as planned and you had to take a step back. I like Dilbert. There's not one that's directly on point here, but as you can see, you've got to be careful with how you do your pilot testing. You want to bring in people who are friendly and who are not likely to react negatively to things that go wrong. And we have some people in our pool of subjects that we use over the years who can come in who we know will give us good feedback on what went well and what didn't. And so that's a good use for those people who've been in your studies multiple times and maybe aren't eligible for those type of studies in the future because of their previous experience. Okay, randomization of participants. There's a couple different things we'll talk about from we talk about randomization, and oftentimes this comes into play when you've got different conditions you're testing, whether that's different crash warning systems or different groups of people. Randomization allows a systematic approach for conducting good research and minimizing bias and learning effects. One of the struggles as we look at this is that things are different at the beginning of a research project than they are at the end. People have more experience with it, they get better over time, and so there's fewer glitches along the way. If I collect all the data from one set of subjects at the beginning of the study, and I compare that to data collected at the end for another condition, how do I know that it's not related to the research process having gotten better compared to what I'm manipulating? So what you want to do is you want to spread those people out across the study to minimize the likelihood that there's going to be problems. So some options for doing randomization are we can randomize when they're scheduled, which is what we often do, but it has some risks because you can wind up with clumping people because you may alternate who you're scheduling, but you just bad luck get a lot of people from condition A that are at the beginning and a lot of people from condition B at the end, and C is kind of scattered throughout. Another option is to do it when they come in for consent, but there's often varying differences between when they're consented and when they actually start to run, particularly if you've got a separate visit for that. And then another one is on data collection dates. So you randomize them on the day they show up. And so, let's say we've got 3 conditions. I would want to run 9 people that day. I would want to run 3 from each condition on that given day. And so there's methods you can use to try and balance those out as you move through. The other thing to keep in mind is you also may have to randomize not just the conditions that they're in, but you may have to randomize on scenario configuration. And this can vary if I've got someone who has a multi-visit study and they've got to come in 3 different times for 3 different exposures to things. I've got scenarios that are slightly different but contain the same elements. And I may want to randomize which one they get which visit in addition to randomizing which condition. The other is if I've got multiple drives that they have to do, and let's say they've got to complete 4 drives, and example I'll give is for some of our vision research where we're looking at people's ability to avoid hazards and also detect signs and read what's on them, both with and in and outside the presence of glare. And so we've got 4 conditions there, and I have to balance which order people get them in so that glare doesn't always come first, and sign detection or sign reading doesn't always come first. And so I balance them out by randomizing what order they get them in. Oftentimes we do this with Latin square designs to kind of balance them rather than using a pure randomization, but then we randomly assign them to an order. So those are some things to consider on the randomization side of things. So can experimenters affect the data? That's a good question. Well, one way of minimizing this is training all experimental staff and data collection staff, because the answer is yes. You can have unintended consequences if you're not sure what you're doing. Small differences in procedure execution can create big differences in the data. Provide an example from back in the 90s when we were doing some work on the old Iowa driving simulator. For those of you who've been around many, many years may remember it. We were trying to do some work where we compared to some test track results. We had written up the instructions that we gave them, and we were trying to compare our results after the pilot test, and our results did not line up to what was seen on the pilot or on the test track that we had data from. We talked to the folks at the test track, and we realized that we had written our instructions slightly differently in the simulator, not intentionally, but there were 3 words that were different in terms of phrasing. We changed it to exactly match what they had on the test track, and our results shifted substantially and then lined up with the data that was collected on the test track. And so you've got to be careful about what you're collecting and how you're phrasing things, because small differences between researchers can have big differences in terms of what data you get out at the end. Some other things to keep in mind are what we hear back from the participant. I hope I gave you the data you wanted. I know what you're trying to find out. Those are two phrases I've heard personally when I've been collecting data, and they both scare me. Because I don't want the participants to give me the data they think I want. I want them to respond to the situation as they normally would, so I can understand how they respond. And if drivers think that are trying to figure out what you're trying to find out, they may change their behavior in response to that, and they may be wrong, or they may be right, but it still is affecting the data that you're getting in the end. So you want to be very consistent, and you don't want to provide hints to what you're looking for to the participants as you're going through things. Scripts are very important for this. We have lots of them. We have scripts for consenting. We have scripts for prepping the person as they go into the simulator. Scripts for responding to questions that frequently asked questions we get when they're driving. The more scripts you have, the less variability you'll have between participants and the less potential problems you're going to have with your data at the end. The other thing is to document. We're going to hit on this over and over again. Document anything that seems odd or might affect how you interpret the data. If you sneeze and the participant looks back at you, that's something that you want to document because they're not looking at the road. And so those are things to capture. Non-compliant participants are another challenge that experimenters can affect. Scripts can come into play here. How you respond if somebody refuses to drive near the speed limit. What words do you use to get them to try and comply? What are you going to do if if you're doing a distraction study and the driver refuses to engage with the secondary task that you've given them to do? We've had that happen. They say, I would never do this when I'm driving. We want to document that as part of our documentation process. At a certain point, you just have to say, this person's not willing to engage in the procedure and follow the procedures that we've laid out, and we've got to drop them from the study. At the end of the day, the experimenter needs to figure out when data is good and when it's bad, and so you want to make sure that you've got a process that's as consistent as possible, and you know when there are problems in the data, and that goes back to the documentation. Jacob, we've got our next interactive poll. We're going to throw up a question here and figure out as a researcher, which of these things do you think might be a problem and which causes you the most concern? So it seems like all these things I find concerning, I think at different levels. Participant asking a lot of questions seems to be a common one. And that one worries me because they're not attending the driving task, and I'm not sure the extent to which they are doing what I need them to do to get good data. The speed limit one is one that concerns me most from a scenario standpoint. We often don't design our scenarios to deal with people who, particularly if you're going to have events happen in them, we don't design them necessarily to work within when they're more than 15 miles an hour over the speed limit. Testing systems sequentially due to changes required between systems in the simulator is something we often have to do. If I've got to change hardware in a system to test it, I can't change hardware multiple times a day in order to test a system. And so we'll often do it sequentially. We just have to be aware that there are risks. Some ways we wind up doing that is we shift the hardware once a day, and we test on sequential days, but we test each system across the study. So those are things to keep in mind. Participants staring straight forward. If they're, that one concerns me a little bit because I'm not sure what they're doing. People tend to scan when they're driving, and if they're not scanning, why aren't they scanning? Uh, are they under the influence of some drug that I don't know about that might infect them? Have they heard from somebody that there's a crash event going to happen and they're focused straight ahead because if they know at some point a car is going to pull out in front of them? I'm going to note that if they don't scan around, I'm going to note that they don't, and it may be nothing, but I'm going to follow up with them afterwards on why they didn't glance around to the surrounding driving environment at the end of the drive after we've collected the data. So that's it for this that one. Jacob, can we get back control? Okay. We're going to fly through some of these as we wind down. The next one is keep it simple. There's a lot of complexities, but at the end, you want to keep the process as simple as possible. Complexity increases mistakes that can be made and negatively impacts the quality of the data. It doesn't mean that we can't have things that are complicated, but don't make it more complicated than it needs to be. For the staff, provide scripts to make it easier to be more consistent. Provide participants with information as they need it, rather than in a block at the beginning of the study. That way, you don't have to worry about them forgetting it. Your memory's not that good. Document it. I've been at this a while. A few years ago, I suspected my memory I was forgetting things, and so I asked my doctor about it. I was expecting some grand concern over my health, and he said, "You're getting older. You need to write things down." Well, that's good advice no matter what, particularly if you're involved in the study. I think this goes back to the question we had earlier. Having a document that tells you what to do when and provides indications of what information you should record are important things. Your memory is not that great. On the bottom right is an example of the front page of one of our chronological records of enrollment where it has information capture on there. And so we've got more detailed ones we can share that have more steps in the process. But we want to capture things as we go along. The last thing I want to capture here is notes to file. If there's a protocol deviation, you want to capture it. So things that are outside what you said was going to happen, but you still allowed the participant to continue. An example of this might be someone who comes in, you've told them not to drink alcohol within 24 hours of their visit. They come in and say, "Oh, I completely forgot I had a glass of wine with dinner last night. That was 20 hours ago." Well, we might take a breathalyzer here and obtain their BAC, find out it's 0, and then still run them, even though that they didn't meet their criteria of being 24 hours without alcohol consumption. So those are things you would want to create a note to file because it's technically a protocol deviation. So that's on the easy side. Some of the more complicated ones are things that wind up having to get reported to the IRB because they're a significant deviation and require a report to the IRB. Maybe it's a drug study and somebody that's not on the research team walks in and sees the person who's being dosed and they're a colleague of theirs. That's a significant problem, and you want to make sure you document that thoroughly so it can get reported. We'll talk a little bit about simulator sickness. We do our best to minimize that by designing our scenarios, and we talked about that previously. There's ways to design scenarios, minimizing braking and successive turns, but we can't design it all out. One of the things we can do is we can screen subjects who are more likely to experience simulator sickness, so we can ask questions during the screening process. If people have a propensity towards motion sickness, we may not want them to be in a study that has a lot of turns and a lot of curves and a lot of braking. Telling participants to let you know if they begin to feel disoriented or unwell. If you provide a general description up front, which is if at any point during the drive you're not feeling well, you want to stop, let us know, and then just watch for what happens. Things we watch for. We've got some training videos they're kind of old and quirky about things that we watch for, but you watch for things like unusual excessive swallowing or closing their eyes repeatedly. Those can indicate, maybe they're starting to feel nauseous, or maybe they're getting some ocular motor issues going on in terms of disorientation because of the flow of the environment. If you suspect something, you want to ask them. You want to find the right time in the scenario when it's safe to ask it without impacting the data. If you're still worried, you can always stop the simulation. This is always it's a delicate balance. We often use a ruse so that they don't get defensive, which is, I don't know how many times we've had simulator failures when people are not feeling well, where we just stop the simulator and say, "Oh, I don't know what happened," and then you tell them, "Oh, the next participant's almost ready, so we don't have time to finish you up today. Thank you for coming in. We're gonna use the data we've got, but we're not going to finish the drive." At the end of the day, we also use Kennedy's simulator sickness questionnaire to get an objective identification of what they were feeling. We can use cutoffs in there for whether or not we can continue them in the data if we do it after a screening drive, or we can make a determination about whether or not the data is valid at the end based on what those scores are. And if they got sick, we may want to replace them. So protocol correct. We've been doing a good job of documenting, so we're going to review that documentation at the end, and we want to know whether or not there are any problems along the way. Were there any problems in the briefing process? They may have asked questions that indicate they know what's going to happen, and if they do, we may want to exclude them from the study, particularly if we can. And I don't like to use the word confront, but we talked to them after the study and we asked them if they'd talked to anyone before they came in, and oftentimes they'll be honest and say, "Yeah, my roommate was a participant in the study, and he didn't tell me exactly what was going to happen, but I knew that something surprising was going to happen." So those are cases where you may want to exclude them because they didn't meet the criteria. Did the simulator drive occur as expected? We've tested these scenarios. We expect everything to work out okay, but sometimes the car that's supposed to slam on the brakes in front of the driver somehow winds up behind them because the driver did something unexpected during the drive. So we want to document those things, and that may mean that we don't want to include it in our analysis if the braking car drove through us in order to get in front of us so it could slam on its brakes. Did the participant get sick? Do we have all the survey data? So we focus a lot on the simulator data, but are the other data that go with it, are they all complete and valid? Is everything in the simulator data present and complete? Sometimes there's something quirky and something doesn't get recorded. You have an incomplete data file. Those are things we care about. Is there eye tracking data, or are there physiological measures that we may have collected in there? So we want to really check and make sure all the data is there and can be linked appropriately between the portions of the study to make a determination about whether or not we can continue with that data and use it. We're going to touch back on simulator sickness. Jacob, this is our last poll. If you could pull this one up real quick. Can you keep the data if somebody got sick? Well, there's no automatic yeses in there, so that's a good thing, because if they got sick, your best hope is it depends, and sometimes the answer is no. So Jacob, let's go on to the next slide. And so, as we said, it really depends. If they got sick after the event you care about, for example, if you're conducting a crash avoidance study and they got sick as a result of the braking maneuver, they started feeling nauseous at the end of the braking maneuver, your answer may be yes. That may be one where it's a very simple, there were no problems observed until they slammed on the brakes, and then the drive is over, and as they start to stand up from the simulator, they tell you they feel lightheaded and nauseous. Well, it probably didn't affect our data at all, and so we're probably good to keep that data, but it's still important to document that. Maybe some data may still be valid. If they got sick partway through, we may be able to keep data up to the point where they started feeling sick. Let's say there was a braking maneuver and they report that they started feeling nauseous after the first one. Well, maybe we can keep all the data up to that first event where they started not feeling well. You're going to want to look at the SSQ data, and you may be able to keep all of the data if it's just eye strain and they report symptoms of simulator sickness that aren't severe and don't necessarily impact, and we didn't see any abnormal behavior. And then no, nausea is generally a bad sign. If they're feeling nauseous during the drive, it generally affects that data, And if they felt nauseous from the beginning, you're maybe out of luck in terms of keeping anything from the data. If there's any outward signs, overt outward signs, that can also tell you that there's problems as well that you want to be cautious of. And so, if they're doing a lot of the eye closures that we talked about, they're not attending to the roadway, and they're doing that to avoid having to look at the road as they're turning. That's not a good sign, and that generally means that the data is not useful. So we're back to checking our data, and this is talking more about the simulated data. One of the last steps is to make sure the data is valid. We're going to check against parameters that we've collected. Were they driving outside the speed range? Maybe there's a note that says that they were driving, slow, and we're not sure that they were in the speed limit. So we want to check and see if they were actually inside the range or outside. And for some of our work, we have hard limits, which if they're not within 10 miles an hour, they're out. And so if they're more than, if they're 10.1 miles an hour faster than the speed limit, they're automatically out of the study. And we check that with our electronic data. Any aspects of the scenario not work as expected. Unexpected driving before the event, unusual driver response. Those are things we want to capture and make sure that those are reflected in the data and make sure we can keep it. There's all the data in the file. We've had cases where we've had data where we think everything's good and we open it up and you've got 2/3 of the data, and at some point during the data collection, the data file just ended and we just don't have any data at the end. So those are things you can all check. You're going to have to replace if there's problems. So if you encounter unusual problems in the scenario or unusual data or data not all being there, you may have to go back and replace it. You want to do that before you get to the data analysis. Because waiting for data analysis is not a great idea because it's too late to do much about it. So if I wait till analysis, I might wind up with a smaller N because all of a sudden I'm throwing out data where people were going too slow and the data isn't the same as the data from everyone else that was in the range. So the last thing I've got on here is documentation determination. And so one of the things that we do at the end is we go through for each subject and we document whether or not we kept their data, and if not, why. We talked about memory before. My memory is not great, and it's nice to know and not have to go back and repeat this by going back to the source documents to figure out whose data is good and whose isn't. And so we go through and we use some color coding and some additional codes to indicate that data was valid or not valid. And so this obviously hides some of the important information. We kind of go through and we give them a code about whether or not the data is good, whether or not they've given video consent for us to use their video for non-research purposes, and we highlight whether or not the data had to be excluded, and if so, we include why the data was excluded from the analysis. And so that's an important tool for going back, whether it's you or one of your researchers in your lab or somebody you share the data with, to understand why the data was used and why it wasn't. And when you get those questions back from the reviewer for your journal article about, can you explain why you lost 20% of your data, you can go back to this and say, here's a table of exactly why we lost each person that we lost, and that we're not cherry picking the data to get the data we want. So data analysis will be your next webinar, and that'll kind of build on where we're at now that we've got some good data. That's Tuesday, April 30th at 3 p.m. And according to Dawn, I'm supposed to go to this slide, and this is where I open it up for any questions. And I realize that we've got about 5 minutes left here for any questions, but I'll open it up to any questions that you guys might have from this presentation. Someone started typing, but I do want to thank everyone for joining us today. At one level, this is kind of the easiest one to talk about. There's lots of war stories I could tell, but then we would have taken 2 hours instead of the hour and a half we did. So one of the questions we've got is, do you use any participant management tools like Ripple, Respondent, Sona, or do you prefer the traditional method? So we are currently we have some internal tools that we use. We've looked at Ripple. It's got a lot of valid pieces to it. I have not looked at the other ones, either Respondent or Sona, but Ripple has a lot of things that we like, but it doesn't do some of the things that we want to do. And so we've been reluctant to make the change. There's some things that they're planning to add that would provide some of the functionality that we have. Right now, we use an Access database for managing our participants, and then we use Excel spreadsheets for tracking things as we're going through in terms of documenting times. And so I'd like a more integrated approach. Ripple provides some of that. We have some plans to try to integrate our tools. And so we're going to make a decision in the near future about whether or not to move to something like Ripple or to expand our tools, particularly as the university here moves to more voice over internet for phone calling. It would allow us to be more efficient when we have to call subjects as well. So there are tools out there. I encourage you to look at Ripple. It does have a lot of value, but the traditional method does work of using your own tools and own spreadsheets to do it. So, any other questions? While we wait and see if anybody else has got a question, I do want to call attention to the Road Safety and Simulation International Conference that will be held here in Iowa City from October 14th to the 17th. So mark it on your calendars. Hopefully we'll see you all here then. It'll be an interesting opportunity to interact with a lot of people doing road safety and simulation work. I think that nicely interacts with the Safer Sim mission. And so I do encourage you to make it here to Iowa City if you can. I know a number of my colleagues are planning on being here. It's unclear if I'm going to be here. There's another conference I'm supposed to be at that's that exact same week, and that's the Association for Advancement of Automotive Medicine. And so I have to balance that out. So unfortunately, I'm not sure if I'm going to be able to be here for that. But I have a number of colleagues here that will be, and so they'll be happy to greet you on my behalf if I'm not able to be here. So with that, Jacob, I think we're right at 4:30, and I don't see anybody else typing. So with that, we'll call it a day. Thank you for being here, and I look forward to hearing next week's presentation on data analysis.